Hi everybody, this is Mr. Ryan again. This is going to be lesson 2.4 for the ninth grade math summer semester. And what we're going to do in this lesson is we're just going to look at shapes of three different kinds of graphs. We're going to look at two different shapes of each different kind of graph and just sort of get a beginning understanding of what these graphs typically look like. You already know one of them, well, two of the six. We're going to look at six altogether because we're going to look at two versions of each of the graphs. You already know what two of them look like, and so we're just going to look at the other ones in addition, okay? All right, so let's go ahead and look at, this one, okay? So what we're looking at here, we're using Desmos here. And I highly recommend Desmos to help you whenever you're, and I'm going to show you in a video in Unit 3 on how to use Desmos to help you with know whether your homework answers are correct. All right, so what we have here is we have a straight line, okay? We call a straight line a linear graph, okay? And so what you're looking at here, and we already know that a linear graph can have different kinds of slopes. This is a steeper slope. This is a flatter slope, okay? In particular, what we're looking at here is when we always read graphs from the left to the right. We move from the negative x's to the positive x's when we are reading a graph. And oftentimes we want to know whether the graph is going up or down as we go from left to right, okay? And so you can see this one is from left to right, it's going up, okay? And so when it goes up, we call that a positive linear function or a positive linear graph. So that's what this one is right here. So I'm gonna write this down. This is a linear, okay? This is a linear, in fact, you should draw this shape, okay? Just roughly draw it, a linear positive, okay? All right, positive graph, okay? And a linear positive graph, we already know that it can have a y-intercept that's positive, so like this is a y-intercept of 4, this is a y-intercept of 5, a y-intercept of 6, a y-intercept of 7. We can even go negative. This is a y-intercept of -1, -2, -3, -4. This is a slope of about 1. This is a slope of about 2. And this is a slope of about 3, okay? And so that's a linear graph, okay? But if we flip this graph so that it's going down from left to right, okay, this is what we call a negative linear, okay? So we're going from left to right, we're going downhill, okay? So we're going downhill as we go from left to right. We call this a linear graph, but it's negative, okay? So we're gonna write that down. Okay, so this is a linear graph. And it's negative. Okay. I don't have my usual pen. This pen tool on my screen recorder is not very easy to use. Sorry about that. So this is we're going from left to right, we're going downhill. So that's negative, and it's a straight line, so it's linear, okay? All right, so that's it for linear graphs. So those are the two kinds of linear graphs that we've seen. Now we're going to look at a graph. It's called a quadratic graph. Okay, so let me write the word real quick. So the word is quadratic. I don't know if you've seen a quadratic before, but we're going to spend some time in Unit 4 on quadratics. Okay, so quad, like 4, okay, quadratic, okay. Now the word quadratic comes from functions. We know that a linear function takes the form y equals mx plus b, right? mx plus b. Okay, that's linear, right? Well, a quadratic, okay, so this is linear. Oops. I'm having a hard time writing. Hang on a second. There we go. This is linear. Okay, we already know that. Well, a quadratic graph squares the x. It does x squared, x times x. A quadratic is x squared, and then it'll go something like plus bx. And actually there will be an a in front of the x squared over here. We'll put an a here. A x squared plus bx plus c. This is the form of a quadratic graph. Now, what do we mean by why quad? Why 4? If this is x to the second power, then why is it quad? Why is it 4? Well, what do we say when we say x to the second power? We say x squared, and a square has 4 sides, right? And so we call, since squared means a 4-sided figure, we call it a square, and that's 4 sides, so that's quad or quadratic. So a quadratic takes this form, ax squared plus bx plus c. Well, what I want to show you now is what a quadratic graph looks like. If we were to graph ax squared plus bx plus c, this is kind of like what, well, let me get a better picture of it. This is kind of like what it would look like, okay? It's basically a U shape. We call this a parabola, P-A-R-A-B-O-L-A, okay, parabola. And it's a U shape, and it can be turned up, or it can be turned down like this, okay? So I always say up like a cup or down like a frown, okay? And this is the positive version, and this is the negative version. This is when the a is positive, so we have a positive x squared. This is when the x squared is negative, when the a is negative, okay? So positive, negative, okay? So this is a positive quadratic, this is a negative quadratic. And let me show you some varying appearances. It can move all around the coordinate plane like this, okay? It can be on the left, it can be on the right, okay? It can move up, it can move down. So let's say we moved it up, and then we move this, and it could be over here, or it could be over here. So it can move all over. These are called translations, and we're gonna learn all about that in a couple weeks, okay? But I wanted you to have a picture of what a quadratic graph looks like, okay? And so I want you to know the up like a cup, the U shape, that's turned open at the top. This is, whoops, what did I just do there? All right, hang on a second, let's try this again. There we go. All right, so this is a quadratic. Okay, I'm just gonna, and then this one is the positive version of the quadratic. Okay, positive version of the quadratic. Okay, so just kind of do a rough sketch of this in your notes. Okay, all right, and now bring this back down here. If we were to flip it upside down, this, whoops, hang on a second, let's change the shape of that. Let's bring this down a little bit. And let's do this. There we go. This, where it's down like a frown, this one is the quadratic, but it's negative. Okay, so it's turned to where it's open at the bottom instead. Okay, it has a peak point at the top. Looks kind of like a mountain. Okay, this is a quadratic. That's supposed to be an A. That's really ugly. Quadratic, and this one is negative. Okay. So this is a negative quadratic. Okay, so that's 2 more. So we've learned the positive linear, and the negative linear. And now we've learned the positive quadratic, and then here's the negative quadratic, okay? And so we only have one more left to learn, okay? The last one that we're going to learn is called an exponential, okay? We're going to learn the graph of an exponential function. Exponential. An exponential function is a lot different than the linear or the quadratic in a lot of ways. Exponential. Okay. All right. So an exponential function takes on the form of y equals. Okay. Oops. That wasn't supposed to be an e. It's supposed to be an equals. I wasn't thinking clearly. All right. Y equals. Really, I was thinking of the letter E, and there's a good reason for that, but I'm not going to talk about it now. All right, so in this case, we have A, and this is the base of an exponent. And then we have BX in the, we have A raised to the power of B times X. That's why it's little. It's up here. This is an exponent, okay? I'm going to draw it larger so that you don't put it in your notes incorrectly. We're doing a big A and then raised to the power of, instead of the power of a number, it's the power of B times X. So the variable, and then we'll have here, we can have plus C is in the exponent, and then coming out of the exponent, we have plus D, okay? And so this whole thing here, this is an exponent, okay? So it's A raised to the power of the exponent, bx plus c. So the variable x is actually a part of the exponent, okay? And so that's how we write an exponential function. But let's go ahead and see what this looks like. What does an exponential function look like? Well, let's do, I need to set it up first. Let's do maybe here, okay? And then we will do here, and then let's start with this one here, and we'll start with this one here. Okay, so this is an exponential function, okay? I don't know if you can see that pretty well. This is really interesting. What happens with an exponential function is it looks very different in the left direction than it looks in the right direction. Please pardon me for a second. I have to silence my phone. Okay. It looks very different in the left direction than it looks in the right direction. So you can see in the left direction, it becomes really flat. It's very flat, okay? In fact, it'll stay flat all the way back to negative infinity. It just goes flat in one direction, and in the other direction, it goes very steep, up, and away, okay? And so I can actually make it easier to see this if I do this. I can bring it down a little bit. Let me move my face over here, okay? And you can see that this exponential function, on the right-hand side, it goes up, and away, and on the left side, it goes flat. That is very characteristic of an exponential function. They're flat in one direction, and they're steep in the other direction, okay? Now this, the one you're looking at here, is the positive version of the exponential, okay? Flat to the left, and then steep on the right. But the negative version looks like this. The negative version is actually steep on the right, or excuse me, flat on the right and steep on the left. It just sort of flips around sideways. Okay, it's called a horizontal reflection, is what it's called. Okay, so this one where it's flat to the right and steep on the left, this is the negative exponential function. But if I go this direction, this one is the positive exponential function. And it can be, let me show you how it can change. It can actually become steeper. It can actually become even less steep. It can not too, but it's still a little steep, okay? It's still flat to the left and steep to the right, okay? And so this is the one we're looking at right here, flat to the left and steep to the right. This is exponential. This is an exponential function. Make sure you write out the whole word here because I want you to get used to writing this word. Exponential. Okay, exponential. And this one is positive, so we're going to put POS. Okay, POS. Okay. All right, there we go. This is an exponential positive. Okay, but now if I reverse it, let's see here. We'll go here. All right, there we go. Now when I reverse it, see, we were over here. Now we're going over this way, where it's steep on the left and flat on the right. That's all you need to know is steep on the left and flat on the right. It's automatically an exponential negative. Okay, so we're going to call this one exponential negative. And I'm just going to put, you write out the whole word, okay? But it's this drawing tool is a little slow. Okay, EXPO, well, I'll go ahead and write the whole thing out. Exponential TIAL. Okay, this one's exponential, but because it's flat on the right and steep on the left, this one's negative. Okay, and so really it just depends on which side the steep is. If the steep is on the negative side, is pointing towards the negative side of the plane, then it's an exponential negative. If the steep part is pointing on the right side of the plane, then it's exponential positive. Okay, all right. Well, that's it for this lesson. That's all I need you to do is be able to identify 6 different kinds of shapes of graphs. Okay, the linear, positive and negative, the quadratic, positive and negative, and the exponential, positive and negative. Okay, all right. I hope you have a great day.